Let's take some notes! Alright, so we are in 4.2, solving quadratics by graphing. So we have our quadratic equations, ax squared plus bx plus c equaling 0 right now. We are going to change the 0 into our y so that we can graph them. We learned how to graph in 4.1 in many variety of ways. So graphing our parabola becomes big here because we can solve by graphing. Y equals ax squared plus bx plus c. When we have our y being 0, so when this equals 0 over here, we have 4 big words to know: solutions, roots, zeros, and x-intercepts. The solutions to the equation are also called the roots. So the equation part, the solutions, the x's that make that true, are also called roots. One way of finding those roots is to find the x-intercepts or zeros of the graph. So on the graph, we tend to talk about roots as x-intercepts and zeros. In the equation, we talk about the solutions or the roots. But really, these 4 things are quite interchangeable, understanding that these are all really talking about the same thing. A lot of time was spent before we had graphing calculators on approximating the roots of the parabola. How do we figure out where these roots of a parabola are? So we're going to go over on our calculator how to do this so that we don't have to painfully figure out by plugging each number in what the y values would be. So we're going to create some tables. Where I want you to start is by putting our equation here into our calculator for y equals. So our y is going to be the 0. So here's our y equals. We're going to plug that in for y1 in our calculator. So go ahead and push y equals. And then in y1, we're going to put x squared minus 6x again plus 2. Once you have that typed in, make sure it's correct. And we are going to hit second. That makes us look at the blue things. So second window is table set. We're going to hit second table set. We want to set table start to -3. And we want to have the change in our table, the delta for the table, to be 1. And then we are going to say, all right, we're going to go second again, and then graph, which will get us the table that we are looking for. So in that table, we are looking for the sign change in the y column. So we're looking for our sign, +2 to -3. We are changing from positive to negative. That's what we were looking for. And so we know in our graph then, since our x is 0 and our y is 2, and our x is 1 and our y is -3, that to get from y equals 2 to y equals -3, we have to cross the x-axis. That's the point that we're approximating. Right now, we know it's in between 2 and -3. So maybe we guess it's 2.5, but we can do better than this. We're going to make another table, and we're going to start this time with 0. And instead of going by 1, we're going to get more detailed. We're going to go by 1/10. So, second table set. We are starting at 0 this time. We want to have a change in the table be by 0.1. And then we're going to hit second again. And we want to look at our new table. This time, we're looking for the sign change again. Looking for the sign change in the y column again from the positive to the negative. We have between 0.3 and 0.4. let's try again and get even closer to the real value. So do it again. Second table set. We want to go from 0.3 by 1/100th. Second table. We're looking for the sign change in the y column. So scrolling through your table, when x is 0.35, y is positive 0.0225. When x is 0.36, y is negative 0.03. So we changed from positive to negative. That's what we're looking for. And that's not quite close enough for me, so we're going to do it one more time. Second table set. We're going to start at 0.35. This time we're going to go by 1/1000th. And then we want to look at the table. So second table. And we're looking for, where does the sign change in the y column? So we find our x and our y values where our sign changes from the positive to the negative. And we say, okay, we're not going to do another one. We're going to say this is as close of an approximation as I want. So my x is about, which one of those is closer, which y value is closer to the x-axis. This one is 0.0013, and this one is 0.004. So this one is 4/1000ths away from the x-axis, while this one is 1/1000th and a little bit, 3/10,000ths. So this is much closer, and so the x where we cross, 0.354. This is, of course, one of the two places where we cross the axis. We could go through and do this again, because this comes back up, and we saw in our first table a sign change over here going this way from one to another around where we cross the x-axis. So we could repeat the process to approximate to the third decimal place the other x-axis also, but we're about to learn a way cooler way to do it anyways. We need to know that our calculator is doing an approximation. Our calculator does not give us the exact value, so a lot of times we have to look at that and understand what it's trying to tell us. If we have another number like 0.9999999, it's really trying to tell us 1. But since it's approximating, it has a harder time doing that than sometimes when we do it and can just factor or solve by another method and say, oh, it's 1. And so since the calculator is always approximating, we have to keep that in mind for how it's giving us our answers. So the part 2 will take you through how to do the cooler version of finding your zeros. Have a good day.